Alrighty, so today we are going to start our second 6 weeks. I know this calendar says that we would start the next week, but we like to stay ahead of the game, and maybe that means we get to have time to do some fun games and activities, especially since on October 10th we do have the PSAT. So today we're just going to do the first two sections of notes. We'll do 3-1 and 3-2, and again, this will give you extra time to kind of stay ahead of the game, especially since we have a holiday and PSAT coming up in October. And of course, if we stay ahead of the game, we always get to do fun stuff afterwards. So keep up with this calendar, and it is subject to change. I will keep updates on it, and hopefully I will get to do more videos with you guys. And that way we can start doing notes at home and we can do homework during class. And doing notes at home should be a little bit easier just because all you have to do is copy stuff down. Then you can ask all the questions that you have during class. So with this, I will have YouTube links for right now, but this will eventually get uploaded to Canvas. So if you are missing class or you don't understand a section of notes, you are more than welcome to go back online and find these notes there that will help you towards your assignments and things of that nature. So today we're doing 3-1 and 3-2. If you notice, this packet is pink. I was thinking October, so breast cancer awareness, why not? And this packet has all of your notes in it. So all I require when you bring to class are these notes. These notes have everything that you need. And then the only thing you'll have to keep up with is this and your assignments, but everything is stapled together for everything that we will cover within this unit. So turn to the first page. We already start on 3-1. And 3-1 is parallel lines and transversals. We kind of dabbled a little bit on this last class, but this is just to help you give a visual representation of what we're going over. So parallel lines are in the same plane, or lines are in the same plane that do not intersect, and they have the same slope and are equidistant. Equidistant is kind of a weird word. It sounds like equal distant, doesn't it? So just think about that. Equidistant is the same as equal distance apart. Okay, so they're equal distance apart, and we all know what parallel lines look like. Do they ever touch? No, they do not intersect at all. So from here, I'm going to at least just draw two lines, and they are aligned, so make sure they have arrows on the end of them. And sometimes they'll have arrows on the inside, knowing that they will never touch at all there as well. Okay, and the symbol for parallel lines are just two double lines here. So if you see those mean parallel lines. Okay. Skew lines are lines that are not on the same plane. They are not parallel and they do not intersect. So these lines, they don't fall on the same plane at all. So what does that kind of look like? I'm going to draw a box, a 3D box. So we will just start off with a square. And make it 3D as possible. Of course, yours doesn't have to be perfect. Mine's not perfect either. And then, of course, there's kind of like that plane that lies flat underneath it, right? So with that, that's like if I had this line and say I had this line. They don't touch and they are not on the same plane. Okay? So they don't intersect at all because they're not on the same plane. Then we have parallel planes. So we have parallel lines. What do you think parallel planes do? Parallel planes do not intersect at all either. So I'm going to draw this box again. And again, we always have that flat plane on the inside. And I'm just going to shade the top and the bottom. So these are parallel to each other. They're still equidistant and they don't touch. So those are parallel planes. Now, if we go into example 1, it says use the figure below to answer the questions that follow. So I have a 3D figure, and I'm going to use my vocabulary words, parallel lines, skew lines, and parallel planes in order to identify what I have before me. So example 1A says, what lines are parallel to line AB? What are parallel lines to AB? Well, I also have DC. So DC is one, and make sure you put the arrows on top. And what else is parallel to it? I also have EF. EF is parallel. These lines do not touch. They are parallel to each other. And then I have example 1b. It says, what are other sets of parallel lines? Well, this is where we use that symbol sign, parallel. So that means parallel to each other, remember? So other sets of parallel lines, we have CB. Let's start off with CB. What's parallel to CB? Oh, DA is. So we say CB, line CB is parallel to line DA. Okay, so that's one set. I'm sure we can think of other sets. What about EA? So EA is parallel to line FB. And then I have one more set I can think of. Let's talk about ED. So I have line ED, and that line is parallel to FC. See? So we have sets of parallel lines identified here based on this figure. Now we have name a pair of skew lines. So skew lines, remember we talked about how they are on the same plane, or they are not on the same plane, and they're not parallel, and they do not intersect. So these kind of just don't touch at all, regardless of where they are. So naming a pair of skew lines, we have CF. So look at CF. You have CF here. And then what about DA? So I have line DA. So DA, they don't lay on the same plane, and they don't cross each other either. We also have CB. So CB is here, and a skew line to CB would be DE. So think of these are also like opposites of each other as well. They might not be parallel, but they definitely are opposites of each other. And feel free to pause as you go through this if you need more time to write. I'm flipping over to the next page. So then we have our last one. It says name a pair of parallel planes. So who are the name a pair of parallel planes? You tell me. You answer that one for yourself. Now we get into this definition of transversal. So transversal is a line that intersects two or more lines in a plane at different points. So this kind of looks like a diagram that we have in our previous notes. So I'm going to draw two lines, preferably parallel to each other. And then I'll have one line intersecting it. Okay? So those are transversal lines. Sometimes they'll be parallel and sometimes they won't. Like these here, they're not parallel to each other. But this is the transversal line that cuts right in between them. Okay? And transversals make different angles. So with different angles, I have quite a few different ones. I have alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles, and corresponding angles. So let's go through these definitions. So alternate interior angles, or you can say AIA, if you abbreviate, that's fine with me, are two non-adjacent interior angles on opposite sides of the transversal. So when I have things on the opposite sides of the transversal, what does that necessarily look like? Well, let's use the diagram on top. So the diagram on top, where I have two adjacent sides, we have two non-adjacent sides, excuse me, so we have two. And then what would be an alternate interior angle? Think of something that's on the inside, but it's alternate from it. So that would be kind of like the opposite of where it is, the opposite side. So what's the opposite of 2, but on the interior still, is 7. So think of it as like they're opposite of each other. So we have angle 2 and angle 7. I'm sure we could think of some other ones. What about 6 and 3? So we have angle 6 and angle 3. So those are alternate interior angles of each other. All right, now we have alternate exterior angles. So alternate exterior angles are two non-adjacent exterior angles, and they are on opposite sides of the transversal. So now on opposite sides of the transversal, again, what does that look like? So that would be something like 5, angle 5, right? And angle 4. So this time they're on the exterior, so only on the outside of the external line. So this is my transversal, and these are on the outsides of that line. So I have angle 5 and angle 4. But what would be another one? Another one would probably be angle 1 and angle 8. And I'm drawing these wider so you know what's congruent to each other and what they're not, because we're going to get into that in just a little bit. So then we have angle 1 and angle 8. Okay? So same side interior angles. You have same side interior angles. They are interior angles on the same side of the transversal, exactly as it says. So if we do that, we're on the same sides as 2, 3. So angle 2 and angle 3 are same side interior angles. But what would be another one? What about 6 and 7? They're on the interior, and they're right next to each other. So we have angle 6 and angle 7. Okay? So now we have same side exterior. So we have same side interior and same side exterior. So same side exterior are the same angles, are the angles on the same side of the transversal. So that would be angles like 5. So it would be from 5, also be 8. And what about 1 and 4? 1 and 4 are the same as well. So we have angle 1 and angle 4. Okay? Then we have corresponding. So corresponding angles are two angles that are in the same, and I apologize, it kind of continues on to the other side. These are two angles that are on the same position and relative to the lines and the transversal. So for this one, for corresponding angles, we're looking at angle 1 and angle 3. So think of it, they're like in the same position. Same position, just different parts. So we have angle 1 and angle 3. Okay, and then we also have 5 and 7. So angle 5 and angle 7. And there's also more in there, but I'm just giving you 2 examples that might help. So those are your different angles that can conspire from a transversal line intersecting other lines. So if you flip over to your back page, we have example 2 here. So we have used the figure below to classify the angle pair and determine the transversal that forms them. So from here, we are using, they give us an angle pair, and we have to tell what type is it. I'm not sure what type they are. So let's start off with example 2, and then we'll talk about angle 1 and angle 5. So I have angle 1 and angle 5. So these look fairly like corresponding. So we have corresponding angles. And there may be times I will abbreviate. Okay? And the transversal line, remember, is that line that cuts right in between those. And so the one that's right next to it is line C. Okay? So now we're looking at 4 and 6. So we have 4 and we have 6. We look at their alternates of each other, right? Or opposites. So we know they're alternating. Again, I'm abbreviating, so they're alternate what? Are they on the inside or the outside of the transversal? Well, here's the transversal. Is it tucked on the inside or the outside? They're tucked on the inside. So these are alternate interior angles. So I'm just going to put alternate interior. And then we have, let's talk about 4 and 10. Oop, I forgot about our transversal. Our alternate interior is also C. Our transversal is C. That's still that line that cuts across it. Okay? Okay, now on to 4 and 10. So we have 4, and now we have 10. These two are what we're looking at. So those, they still look like alternates of each other, but are they going to be in the outside of this transversal line or the inside? It looks like they're on the outside. This would probably be your inside. This is your outside. So these are alternate exterior angles. And what is that transversal line that lies against it? That would be line A. Okay. So 2 and 9, so you have 2 and 9, our next ones. So 2 and 9, I can tell they're probably on the inside, but they look like they're on the same side of the transversal of A. We know our transversal is A, but now, are they on the inside? Are they alternate? Are they on the interior, the exterior? We can tell they're on the interior, they're on the inside, but they're also on the same side. So these are called same side interior. Okay, now let's talk about 4 and 12. 4 and 12, if you see the pattern here, 4 and 12, these are corresponding. Our next one is 3 and 9, so I have angle 3. Maybe I'll switch to another color. So I have angle 3 and angle 9 again. Okay, so angle 3 and 9. Angle 3 and 9, they look like they're on the interior. This is, I apologize, it's transversal A. Angle 3 and 9 are definitely on the interior, and they're alternate to each other. So we have alternate interior angles. And what is the transversal line that it lies on? That would be line A. Okay, so I have 2 and 7. 2 and 7. I have 2 and 7 here. So these are definitely on the exterior, and they look like they're opposites of each other, so these would be alternate exterior angles. And what's the transversal it lies on? And this time it switches up again. This is on C, line C. It's right up against this line. And we have 2 more to go. So we have 3 and 12. So 3 and 12, they look like they're on the same side. Okay? And they're on the insides of the transversal. So these are same side interior. Okay? And the transversal it lies on will be A. And then our last one, we have 1 and 7. As you know, we didn't talk about 11 very much. But we have 1 and 7. 1 and 7. And these look like they're on the outside, so that means they're on the exterior. But they're also on the same sides of the transversal. So this is same side exterior. There's a same side exterior, and the transversal that it lies on is line C. Okay, so these are examples of the type of angles that you'll have and the transversal that it lies on. Try not to get confused on corresponding and same side or alternate. Remember, alternate, think of the opposite sides of each other. The same side will always be tucked together, and then your same side exteriors will always be on the other sides of each other. So think what's tucked on the inside and what's tucked on the outside of those lines. Okay? As we turn the page, we are on to 3-2 already. So 3-2 are parallel lines in algebra. So this time we're taking what we talked about with transversal lines and we are applying it with algebra. And again, we talked about how geometry and algebra are slightly different, but you are always going to need algebra, and math will always piggyback off of each other. So we're starting with 3-2. And so 3-2. We are talking about transversal. It says, when parallel lines are cut by transversal, which pairs of angles are congruent? So with this one, I will give these to you. So for number 1, you get corresponding angles. So corresponding angles are congruent. And there are other ones that are alternate interior angles and our alternate exterior angles. And we talked a little bit about congruent. Congruent kind of means that they're equal, but we can't really say angles are equal to each other. We have to say congruent. So congruent, we always have this symbol. So think you still have your equal sign beneath it, but we have to put that squiggly line there that shows that they're congruent to each other. So these three, if you ever have any that are corresponding, alternate interior or alternate exterior, these will always be equal to each other. Not corresponding equal to alternate interior, but if you have two on that side, or you have two angles and they're alternate interior angles, set them equal to each other. Okay? So that's what congruent is for. Our second question asks, which angle pairs are supplementary? So we talked about supplementary. And supplementary is where you have two angles. So I call this one A, and I have angle B, and they equal a certain amount. Now, complement was 90 degrees, so that means supplementary is 180 degrees. And that means we have to add them together. They add up together to give me 180 degrees. And we talked about that one in notes 1.6. So if you have those 1.6 notes, don't throw them away just yet. You'll always need them for something. Never throw away your notes unless it's the end of the semester and I say so. So it says, which angle pairs are supplementary to each other? So this, your same sides will always be equal to 180 degrees. So you'll have your same side interior angles, and then you have your same side exterior angles. So remember, if you have a pair of angles that are same side interior or same side exterior, these angles will add up to give you 180 degrees. Okay? So this time, this asks which angle pairs are always congruent, regardless of whether the lines are parallel. Now we kind of talked about these lines in 1.6, or these angles in 1.6, and we also kind of talked about them in our last unit in chapter 2. And the answer to this one is vertical angles. So vertical angles are always congruent regardless of whether the lines are parallel. So we have, remember we talked about vertical angles kind of have that V shape, and they kind of create a wide X, and we always said this side was congruent to that side, and the little parts were congruent to the other parts. Okay? Those were vertical angles. Our next question asks, which angle pairs are always supplementary? So which ones add up to 180 degrees, okay, regardless of where the lines are parallel. So we talked about these angles again in 1.6. Like I said, do not throw them away. And so it says what lines are parallel, and this is a linear pair. So linear pairs is where you take the ones right next to each other, and if you were to add them together, they give you a straight line, and a straight line equals 180 degrees. Okay? That's a linear pair. They're always supplementary, regardless of whether the lines are parallel. Okay? So now we're going to take these and use these with some numbers. So example 1 says, tell what type of angle pair each is, and tell whether they are congruent or supplementary. So remember we talked about those arrows. Definitely showed us that they're parallel to each other. So A says angle 1 and angle 3. Angle 1 and angle 3 are corresponding angles. And if they're corresponding angles, they are congruent. Okay, so I'm going to put that congruent symbol so knowing that they're equal to each other. So angle 1 equals angle 3. Okay? What about 3 and 6? Now we're talking about 3 and 6. 3 and 6 are alternate interior angles, and these are also congruent to each other. So angle 1 and angle 3 and angle 6 are congruent to each other. These are the same number. Then we have 4 and 5. 4 and 5 are a little different. So 4 and 5. 4 and 5 are definitely on the exterior, and they're definitely opposites of each other, so these are alternate exterior angles, and alternate exterior angles are congruent to each other. So angle 4 and angle 5 are the same ones. Okay, then we have 2 and 3. So 2 and 3. So I have 2 and 3. So 2 and 3 look like they're on the same side, chilling right next to each other. And so these are same side. Now they on the inside or the outside? They are same side on the inside, so they're interior. So same side interior angles. And same side interior angles are supplementary. Okay? So I'm going to put a little comma and put supplementary. So you can put that and 180 degrees. Know they have to equal 180 degrees. So I would take angle 2, add it to my angle 3, and remember it creates that straight line, so it would be 180 degrees. Okay? And then I have 1 and 6. 1 and 6, maybe if it helps if you turn it slightly, we have that weird looking X. And so if you guessed it, yes, angle 1 and 6 are vertical angles. So vertical angles. And with vertical angles, they're opposite, so they are congruent to each other. Okay? So that's how we can tell what's congruent, what adds up to supplementary, and vertical angles are congruent. Okay? Flipping over to the next page. Oh, we have one more on the back. I know I can't flip over to the front side, but this one asks for 1 and 4. So angle 1 and 4 are actually same side exterior, and with same side, remember they don't equal each other, they are supplementary. So think S, same side supplement, same side supplement, same side supplementary. And supplementary is 180 degrees. Okay? So that was F. So now we're going to add in the algebra. Yes, I know you're always going to need the algebra part. So for those who did well in algebra, you got this. And for geometry kids who like the logic part, I know you got this too. So let's talk about it. So let's talk about example 2. For each of the examples below, identify the type of angle. So you have to tell me the type of angle pair it is. And then given the lines L and M, they are parallel to each other. It does define that they're parallel. Find the value of x. So let's start with our first part. It says identify the type of angle pair. So if I identify the type of angle pair, I have 2x minus 10 on one side, and then I have 3x minus 40 degrees on another side. So what type of angle pairs are these? They're definitely on the opposite sides of the transversal. So I think opposite, I think alternate. So I know they're alternate. But are they on the outsides or on the insides of the transversal? They're on the inside, so that means they're on the interior. And if I have alternate interior, do they equal 180 degrees or do they equal each other? Now, if we were to look back at our notes, we know alternate interior angles are equal or congruent to each other. Got to use that term more, congruent, congruency. So if they are congruent to each other, how would I set up this equation to solve for x? Well, set them equal to each other. So I will take my 2x minus 10 and set it equal to my 3x minus 40. And from here, I will solve for x. I'm going to subtract 3x from both sides. So 2x minus 3x, I end up with negative x equals 40. I add 10 to both sides. So I now have negative x equals 50. But I got to get rid of that negative, and you can always divide by negative 1. Remember, there's always that imaginary 1 right there in front of the x. So I divide by negative 1. Oh, I apologize. This is a negative 40. Again, mistakes are made, but this is how you recover from them. So I have negative 40 plus 10. That is not 50. That is a negative 30. Okay? Negative 30. And when I divide by negative 1, x is now a positive 30. So x is 30. Again, mistakes can be made. It's how you recover from them. Okay? So let's go on to example 3. So example 3 is identify the type of angle. So they're definitely looking like they're in the same position but different spots. So they have to be corresponding angles. So they're corresponding angles, and corresponding angles are, you guessed it, congruent to each other. So again, how am I going to set up these equations? I will set them equal to each other. So I have 4x minus 30, and it equals my 2x minus 14. I'm going to add 30 to both sides. So then I have 4x, that equals 2x plus 16. Okay, subtract 2x from both sides. So I now have x, or 2x, now equals 16. When I divide by 2, 2x divided by 2 is the cancel out, so I'm left with x, and 16 divided by 2 is 8. And so I have solved for x, and x is 8. Okay, now I have example 4. Example 4, they're on the same side, they're really close to each other. So if they're on the inside and they're really close, they're on the same side, so I know it's same side. But they're same side what? On the outsides or the insides? They're on the insides. So that's same side interior. So if they're same side interior, how would I solve for x? Well, we talked about SSS. So we have, on the top part, same side supplement. So supplementary is 180 degrees. So there's supplementary, and I'm abbreviating. So I have 180 degrees. So when we talk about supplementary, they have to add to give me 180 degrees, right? So I'm going to take these two equations and add them together. So I have 5x minus 32 plus x plus 8, and it equals supplementary degrees, which is 180. So I'll set it equal to 180 degrees. Make sure you add like terms. So 5x plus x is 6x. Then I have negative 32 plus 8. And again, if you have a calculator, you're more than welcome to do this. But it is 6x minus 24 equals 180 degrees. I will add 24 to both sides. So now I have 6x equals 204. And when I divide by 6 on both sides, I now have x equals 34. And I ran out of paper on this side, so you can put down here x equals 34. But it does continue on to the next page where it says x equals a blank. Okay? So on the top, weirdly done, x is 34. Okay? Example 5 gives me 2 lines and 1 transversal going through it, just as before. Okay? And so now it says example 5, it says if angle 1, let's go ahead and identify angle 1, is 7x minus 3. Helps to label as you go along, one step at a time. And then I have angle 5 is 8x minus 19. Find the value of x and angle 4. So we need to find this part. We don't know what that is yet. But what can I tell about 7x minus 3 and 8x minus 10? What can I tell about 1 and 5? Let's identify what kind of angle it is. So step 1 is identify the angle. So identify the angle. Okay? So what kind of angles are they? So 1 and 5. They look like they're opposites of each other. When we say opposite, they're alternate. So I know they're alternate. And they're definitely on the outsides of the transversal. So it's alternate exterior. And when they're alternate exterior, they are congruent to each other. Okay? All right, and then step 2, go ahead and set the equation. So step 2 is, we know that they're congruent, so I'm going to set my equation equal to each other. So I have 7x minus 3 equals 8x minus 19. Okay, I'll add 3 of both sides. So I have 7x equals 8x minus 16. Subtract 8x from both sides. And it's okay if you have a negative. So I have a negative x equals negative 16, but we gotta get rid of the negative first. So if I divide by negative 1, I get a positive x, and it equals a positive 16. So now I have x is 16. But am I done here? I'm not. I have to find angle 4. Now how would I do that? Well, what do I know about 4 and 5? They're right next to each other. And let's see, if I were to cover this part, don't I have a straight line? So if I have a straight line, these two angles give me how many degrees of a straight line? 180. So these are linear pairs. 4 and 5 are linear pairs of each other. So for step 3, I have to find angle 4. So, but let's go ahead and talk about, I got to find out what 5 is, or at least what 1 is. 1 is smaller, so maybe I can solve them in. They're equal to each other, so I'm going to plug in x equals 16. So let's talk about angle 1. So angle 1 is 7x minus 3. So plug in x. X is 16. So I have 7 times 16 minus 3, and that gives me 109 degrees. So if angle 1 is 109 degrees, what is angle 5? Angle 5 is also 109 degrees. So angle 5 is also 109 degrees. Okay, so last step 4, to find angle 4, if I have 4 and 5 as a linear pair, I have 109 degrees here, and the whole thing must give me 180 degrees. So what will I do? I will subtract. So I have 180 minus my 109, so angle 1, or angle 4 is 71 degrees. Okay, so identify that these two are a linear pair. Pardon my spelling. Okay, so we're going to do the same thing for example 6. So example 6 is if angle 3 is 8x plus 3 and angle 4 is 20y minus 3 degrees, and then I have angle 7 is 11x minus 12 degrees, find the values of x and y. So step 1, identify the angle. So let's talk about 7 and 3. 7 and 3 look like they are alternate interior angles. So I'm abbreviating interior angles, and that means that they are equal to each other. So I'm going to set angle 3 and 7 equal to each other. Especially helps since they both have x. I wouldn't want to add it to y because that wouldn't make any sense. So I'm going to set them equal to each other. So I have 8x plus 3 equals 11x minus 12. Going to subtract 11x, and I can also subtract 3. Again, I'm combining steps, and that's okay. If you want to do one step at a time, that's perfectly fine by me. 3's will cancel out, the 11x will cancel out, so I am left with a negative 3x equals what's left on this side is negative 15. Divide by negative 3, x equals a positive 5. So I found x. Now how do I find y? So step 2, in this case, is let's find angle 3. Let's at least find that, because we know if we add these together, they have created a straight line, which equals, yep, you called it, 180 degrees. So 3 and 4 are a linear pair. So let's go ahead and find angle 3. So angle 3 is 8x plus 3, right? But we know what x is, so let's just plug it in. So x is 5, so 8 times 5 plus 3 gives me 43 degrees. Okay? So that means to find angle 4, I need to subtract. So I have 180 minus 43. So angle 4 is 137 degrees. So I know what that is, but I need to find out what y is. What is y? But if I know this equals 137 degrees, can't I just solve for y that way? I sure could. So step 4, I can take my angle 4, and we know that equals 137 degrees, right? But it also equals 20y minus 3. So solve for y. So I will add 3 to both sides, and I know I'm running out of room, so I'm going to write it kind of small on this side. I apologize in advance. So I have 140 now equals 20y, and I divide by 20. Y now equals 7. So I found my y and x. Okay? Alrighty, so I hope these notes were super helpful. This was my first time doing it. Please do not judge. If you are confused, please feel free to come and see me. I have tutoring after school Wednesdays and Thursdays, and then before school I'm normally here at 7 o'clock. If you have questions, I'm also on Remind. And again, these notes will be on YouTube, and I will try to get them on the Canvas as soon as I'm able to figure that out. But if you have any questions, you know where to find me, or you might always go to tutoring to another teacher. And the assignments that go with this will be 3.1 and 3.2 practice. So go ahead and get started. Thank you.